Okay, so as I mentioned previously in the previous practical, so this week we are going to continue, right, for the analysis. All right, so I'm going to share the screen for the manual, all right? So as you can see from the manual, the analysis, the other analysis are quite similar with the previous that we have done or we have learned in the online classes. So you need to carry out the NSSA, you need to carry out OD, right? The NSSA to check for the glucose consumption, how much glucose is being consumed, right? For by the Clostridium, and then optical density is for you to check the growth profile, right? Okay, and then this is the analysis that is very specific for the product that is produced, right, from the fermentation, which is acetone, butanol, and ethanol fermentation, right? So for this acetone, butanol, and ethanol fermentation, there's no way other than GC for you to determine the concentration of acetone, butanol, and also ethanol, right? So, but before you analyze your sample, before you analyze your sample, you need to prepare standard as usual, right? As what you did for glucose, right? So you need to prepare the standard. All right, to determine the acetone, butanol, and ethanol concentration produced, right, by the Clostridium in the fermentation, how many standards that you need to prepare? Guys? Three, right? 3 different standards, all right? So you need to have standards for acetone, you need to have standard for ethanol, and you need to have standard for butanol as well, right? So 3 different standards. Okay, so the preparation of the standard is similar for all 3, all right, except you need to have the pure solvent, pure ethanol, pure butanol, pure acetone, right, to be used as standard. Okay, that's for standard. All right, so for the sample, you need to do preparation as mentioned here in table 4. All right, so you can see, okay, this is for preparation of standard. You need to have prepare for 1% standard solution with different concentration. You see here is different concentration, but in the chromatogram that I gave to you, we use different concentration which are 0.4, 0.8, 1.6, sorry, 1.2, 1.6, and 2. Okay, it doesn't matter as long as you have at least 4 to 5 points to construct your standard curve, right? As usual. Okay, and then, okay, this is your standard. It's either A, B, or E. Okay, and then this is 1 propanol. All right, so 1 propanol here will be used for the internal standard. All right, internal standard. So what is internal standard? You have standard A, B, and E, and you also have internal standard, which is 1 propanol. What is the function of internal standard? Anyone would like to answer?
A control.
Control, yes. More accurate answer? All right, so for example, you have this, for example, to prepare for acetone, right? So as I mentioned, you need to have 4 to 5 different concentration. Let's say you have 0.4, right? 0.4% concentration. So you need to prepare 1% of this 0.4, you add with 1% of propanol in the same solution. That means they need to have mixture of acetone and 1 propanol in the solution. Understand what I mean? Understand, guys?
Yes.
Okay. So for each concentration, for each different concentration, you need to add this 1 propanol as the internal standard. All right, so it's for acetone, for butanol, for ethanol, and also for your sample. You need to have this internal standard. So what is the purpose of adding this internal standard? Okay, that is mentioned as a control. Right, so it is actually to make sure that um, um, your sample or your standard is prepared correctly. Right, so for example, when you analyze it using GC, you supposedly will get two different spectrum. So if you have two different spectra, so if you have only one spectrum, so that means your sample got something problem. So you need to re-prepare your sample, right? So for example, it is actually as an indicator for you to show whether your sample is prepared correctly, whether you have stored your sample correctly or not. Otherwise, if you only have one spectrum, so you need to repeat lah the sample preparation, or you need to repeat the experiment, right? So in here, he mentioned that you need to filter the sample, right? So for any advanced instrument that require injection through column, all right? So usually we have a limit, what is the size of molecule that can pass through, so you need to filter. Okay, otherwise, if you do not filter your sample, it will block, right, your sample. The molecules that present in the sample will block the column, so the column will be stuck and you cannot use the column anymore. And bear in mind, for the high advanced instrument, the column itself is very, very expensive, right? So please, you need to prepare the samples correctly before you can proceed with the analysis. All right, so here you need to filter the sample using 0.22 micrometer of nylon derived filter. All right, so into a new tube. All right, so what you need to do is you need to transfer. Okay, then we usually need to dilute the sample. All right, so usually for the advanced instrument, the concentration that is required is actually very, very little. You don't have to inject very much or very high concentration of the sample. So the dilution is usually required. So here you need to dilute. So here they mentioned you need to prepare 450 microliter water. You add 50 microliter of supernatant. Right? This is your sample from your fermentation. Right? Just as I mentioned, just imagine that you have done the sampling, for example, every day, and then the sample you need to centrifuge, right? And then you got the supernatant. The supernatant will be used for the analysis, right? But you need to dilute, right? Just take 50 microliter, you add with 450 microliter of purified water. Okay, this will give you 10 times dilution. So later you need to multiply back with 10 after you carry out the analysis. Okay, and then you add this internal standard, right? 500 microliter. So it will be 1-to-1 ratio, all right, with the internal standard. And then once you prepare this, you need to filter. Okay. Okay. So any questions regarding the preparation? Are you guys clear about the internal standard and also the dilution and the filtration? Okay. And then once you prepare, okay, as I mentioned before, you need to prepare standard before you analyze your sample. So go for standard first, make sure your standard is good. So as usual, the standard curve, you remember, right, how it looks like. So it needs to be straight line, possibly R squared near 1.99.98, right? then it will be good to be used for your analysis, right? Once you have a very good standard, then you can start preparing your sample. So in this manual, we do not include the parameters for GC analysis. Okay, so the parameters require, for example, what is the flow rate, what is the gas that should be used, right? The gas will be used as carrier. All right, what is the column? What is the GC instrument that will be used? The model, all right? So what is the oven temperature? All those parameters, I hope you can search in the journal papers and try to find what are the parameters that should be used in GC analysis of ABE. Okay, okay guys? All right, so for the GC analysis, you need to, okay, once you prepare everything, you need to inject the prepared standard solution, okay, for all concentration into GC, and you need to plot the standard curve of area of 1% of 1 propanol to standard solution. So I'll explain this in detail how you are going to prepare and calculate for this. And then you need to inject the after you prepare the standard solution, as I mentioned, then you can inject the sample. Okay. All right. Is it clear, or am I too fast?
Clear.
Also, can you repeat on the parameters that we need to find?
Sorry, again, Tonset.
Can you repeat on what parameters we should look for?
Okay, so usually when you try to find the method, right, for GC analysis, all the parameters should be explained in detail in the we call it in the paper, all right? So for example, what is the model of the GC? Okay, this could be any model. For example, the commonly used is Shimadzu. All right, so what is the model? What is the column that can be used? All right, so the column, okay, I'll show you the YouTube video later. The column is specific for different compounds that you want to detect. Okay, for example, for ABE, if you are using Shimadzu brand, so the most popular column used is BP20. B, Britain, P, Poland, BP20. All right. And what is the type of detector used for GC? For example, we usually use flame ionization detector. All right. So don't worry, I'll show you the video later. But this is the among the things that you need to list, all right, for the GC analysis method. All right. So what are the solvents? The solvent that can be analyzed, of course, A, B, and E, right? What is the temperature of injector? Okay, when you inject the sample, they need to have certain temperature, all right? So set temperature that should be set for GC. And what is the temperature that should be set for detector? Right? What is the temperature that should be set for oven? Right? What is the flow rate? What is the gas that should be used as carrier? Right? Okay, that's among the thing that you need to list. Okay, don't worry. Usually when you go through the paper discussing about GC analysis, so all of these things usually listed in one paragraph of the methodology. So you will get, if the paper is good lah, you will get all those information. So please make sure that you are citing a good paper, right, to get this to get this method. All right. You know, right, how to get a good paper? The indication of good paper, usually, what is the indication of good paper? Guys? What is the indication whether the journal paper is good or not?
High citation number.
High citation number, yes, can be. And it also is if the paper is published in for example, in Q1 or Q2 journal, all right, in high impact factor journal, then that will be a good paper lah usually, right? Because it is not easy to publish in high quartile, right, Q1 or Q2 journals. Okay. Okay. So any questions before I proceed with YouTube? No?
No.
Right. Okay, so I'll start share with YouTube video. For YouTube, I have two different videos. Okay, the first one is very simple. Just to recap what I have mentioned, what I have explained. Right, so how the chromatography injection looks like, and the second video is a bit detailed about BGC. I'm going to share the second video. So that's the first video only to show how you can inject your sample. All right, but please bear in mind, before you inject your sample, usually we flush, right? We flush the GC, right, the column with the purified water to make sure there is nothing left, the compound that I mean the remaining compound from the previous analysis. You don't want to contaminate your sample. So usually we flush for at least 3 times, right, with the purified water before you can inject your sample. And then after you inject your sample, you need to flush it again for 3 times to make sure that the column is clean. Right, so the column shows in the video is the capillary column. You can see is a circle, it looks like a circle, right? Different sizes, some are very long, like 10 meters long. That's why it is in the spiral form, right? And it's very fragile. Right, it's very small and it's very fragile, so you cannot drop it. When you drop it, the column might be broken, right? So you need to be very careful when handling with the column, right? So as I mentioned, the column is very specific for each compound. So if you want to analyze different compound, you need to check what is the suitable column that need to be used, and then you need to change the column, right? So I'm going to share with you the second video. Okay, guys, for the sample, as I mentioned before, that you need to flush your sample before and after use, and you also need to make sure that there is no bubble present inside the syringe, right? Otherwise, it will affect the compounds that you injected into the GC, right? Another thing that I would like to highlight is from the video is GCMS, right? So MS, right, mass spectrometry is actually additional, we call it additional unit, all right, for advanced instrument, much more advanced. It's mentioned that if you don't know what the compound is, okay, MS usually they got library of the compounds that you can actually identify what are the compounds. But in this case, if you want to just analyze A, B, and E, you already know they got A, B, E in your sample, and you're only interested in A, B, E, you can only use GC without MS, because GC-MS is more expensive, right? What else? Okay, about the auto injector, they showed in the video. The video is actually quite old, all right? So the current or the recent technology, most of the GC they come with auto injector. So even though for a normal GC, all right, so you basically you just need to prepare a sample, put it on the auto injector. So auto injector will do the work for you automatically. They will inject the sample automatically without a need for you to inject one by one of your sample.